H&M.
What's up, H&R?
It's been a good training session. I'm pretty impressed with the trainees so far. What about you?
Oh yeah, they've been really responsive.
It was pretty cool. We had actual live footage for the training video there.
Yeah, I could have done without the Sector X debacle though.
Whew, tell me about it. Who knew that? Okay, let's go ahead and get to our recap.
Recap it is.
All right, H&M. We started with unmasking the trig expression. We had three main strategies. 1, convert everything to sines and cosines. 2, factor out a GCF. And 3, find a common denominator. With these three strategies, we were able to unmask the alien.
Those were our three strategies, Agent R. Let's try one. Secant theta divided by cosecant theta. Secant theta divided by cosecant theta. Pause and try that one. All right, secant theta divided by cosecant theta. Agent R. First, we want to change everything in terms of sine and cosine. So secant theta is 1 over cosine. Cosecant theta is 1 over sine theta. Then we have division by 1 over sine theta. So we got to multiply by the reciprocal. So we're going to have 1 over cosine theta times sine theta over 1. So that's sine theta over cosine theta. Sine over cosine. Oh, that's just tangent theta. Agent R, you want to give one a try?
All right, Agent M, what do you got for me? Cotangent theta minus cotangent theta times cosine squared theta. Once again, trainees, you give this one a try. Cotangent theta minus cotangent theta times cosine squared theta. Okay, let's see how you did. We start with a GCF, so I'm going to factor out a cotangent theta, leaving 1 minus cosine squared theta. Next, let's go ahead and go to sines and cosines. Well, cotangent is cosine over sine. 1 minus cosine squared theta is a Pythagorean identity in disguise. So we can easily manipulate sine squared plus cosine squared equals 1 and find that 1 minus cosine squared is sine squared theta. So we end up with cosine theta divided by sine theta times sine squared theta, at which point one of the sines divides out, leaving cosine theta times sine theta. Okay, I hope you're feeling better about these. Agent M, what's next?
All right, Agent R. So we've done one where we just converted to sine and cosine. Then we've seen a factor out one. So let's see one where I may or may not have to find a common denominator. Okay, so what about sine theta plus cosine theta times cotangent theta? Trainees, pause and try it. Sine theta plus cosine theta, cotangent theta. First of all, I see a cotangent theta in there, and I see other sines and cosines. So it's going to be the best for me to use quotient identity to convert my cotangent theta into cosine theta over sine theta. So that's going to be my first step. Then I notice I have a fraction and I have a plus sign, so I'm already thinking common denominator. So let me write sine theta over 1 plus cosine theta times cosine theta over sine theta for my cotangent theta. Okay, so now I want a common denominator. The denominator on the right is sine, so I'm going to multiply my first term by sine theta over sine theta. Okay, so for the first term in my numerator, I have sine times sine, which is sine squared theta, plus cosine times cosine is cosine squared theta, now all over sine. Okay, sine squared plus cosine squared, that's like my favorite Pythagorean identity, 1. So 1 over sine theta is cosecant theta. Got it. What else did we learn other than simplifying trigonometric identities?
Oh my gosh, how could you even forget? It was the Sector X debacle. So we have to solve trigonometric equations, and we did that by isolating the trig expression, factoring out a GCF, or factoring quadratic form. So let's try one. Okay, Agent M, let's just do a couple of these solving equation ones. So 4 sine squared theta plus 2 sine theta equals 0. Make sure you notice it's equals 0. That affects what I can do right now. Pause, try this one. Okay, so the first thing I notice is that it is set equal to 0. So we can go ahead and look for a GCF. And in this case, we have 2 sine theta that they both share. So factoring out a 2 sine theta, I have 2 sine theta times the quantity, 2 sine theta plus 1, equals 0. Now I employ zero product property, and I have 2 sine theta equals 0, 2 sine theta plus 1 equals 0. I'll go ahead and divide out 2, and I get sine theta equals 0. Now we need to go look at our unit circle and just get where that happens. So sine theta equals 0. Oh, right here we have the point 1, 0, and over on the other side, negative 1, 0, because I know I'm looking for the y coordinate to equal 0. We see that that happens at 0 and pi. I don't include 2 pi because in the directions it said from 0 inclusive to 2 pi non-inclusive. Next, I'll solve 2 sine theta plus 1 equals 0. So subtract 1 from both sides, divide out 2, and we get sine theta equals negative 1/2. Okay, where is the y-coordinate? Negative 1/2. Well, in quadrants 3 and 4. So in quadrant 3, we see that we have negative root 3 over 2, negative 1/2. And in quadrant 4, we have root 3 over 2, negative 1/2. Where did these occur? Well, let's count it out. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6. So 7 pi 6 and 8 pi 6, 9 pi 6, 10 pi 6, 11 pi 6. 11 pi 6. So theta equals 7 pi 6 and 11 pi 6. The answer for this equation, theta equals 0, pi, 7 pi 6, and 11 pi 6. Remember when we do the online assessment, we put them in order least to greatest. All right, I hope you're feeling pretty good about the recap, trainees. Let's do one more equation. Agent M, you got this.
Of course, Agent R. I just love factoring quadratics. Okay, let's try this one. 2 cosine squared theta plus 3 cosine theta equals negative 1. Pause, you try. 2 cosine squared theta plus 3 cosine theta equals negative 1. First thing I noticed here is that it doesn't equal 0. So I'm going to add my 1 to the other side right away to take on that true quadratic form. 2 cosine squared theta plus 3 cosine theta plus 1 equals 0. So now I can factor. That way I can use zero product property to solve. Okay, there's a 2 in front of the cosine squared theta, so I'm going to use guess and check method. 2, 2 and 1, the only things that multiply to 2. 1, 1 and 1 are the only things that multiply to 1. So 2, if I multiply across, 2 times 1 is 2, 1 times 1 is 1. Add those together, I get 3, which is the coefficient of the middle term. Killing it. So I'm going to go ahead and hug these and get 2 cosine theta plus 1 as one of my factors, and cosine theta plus 1 as my other factor equals 0. Okay, so here we go. 2 cosine theta plus 1 equals 0. I'm going to subtract 1, divide by 2, cosine theta equals negative 1/2. Now let's head on over to my unit circle. Here we go. Unit circle, cosine is the x-coordinate, it's negative, so I'm going to be in quadrant 2 and 3. Okay, so if I get those drawn on here, I have this coordinate here at negative 1/2, comma, root 3 over 2, and negative 1/2, comma, negative root 3 over 2. All right, those are at my pi over 3s. So if that's 1 pi over 3, then that would be 2 pi over 3, and then 3, 4 pi over 3. All right, so my possible thetas so far are 2 pi over 3 and 4 pi over 3. Okay, cosine theta plus 1 equals 0. Subtract the 1, cosine theta equals negative 1. Hey, that's actually a possible answer too. Head back over to my unit circle. Sine's the x-coordinate, that's a quadrantal. So negative 1, that's right here, that's at pi, negative 1 comma 0. Okay, so then I want to list my theta values in order from least to greatest. So if I look at my circle, that would be 2 pi over 3 first, then pi, then 4 pi over 3. Boom, boom, thetas.
Hey, Agent M, remember that one situation where we ended up with a problem where we had something out of range? Let's take a look at that. So what happens if we had sine theta equals negative 4? Well, negative 4 is out of range for sine because we know the sine goes from negative 1 to 1 on the y-axis, and same with cosine. So remember, anytime you get something bigger than 1 or smaller than negative 1, it's out of range. No theta! Theta, see you later. Theta, see you later. Theta, see you later. Math and Black, out.
Recall reciprocal identities. Secant 1 over cosine. Cosecant 1 over sine. Cotangent 1 over tangent. Quotient identities. Tangent sine over cosine. Cotangent cosine over sine. Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. 1 plus tangent tangent squared theta equals secant squared theta. 1 plus cotangent squared theta equals cosecant squared theta.